Hello friends, today we are going to discuss types of semiconductor, what are intrinsic and extrinsic semiconductors, types of impurity, trivalent and pentavalent impurity, what are p-type and n-type semiconductors. First, types of semiconductor. There are two types of semiconductors, intrinsic or pure semiconductor and extrinsic or impure semiconductor. Extrinsic semiconductors are two types, n-type semiconductor and p-type semiconductor. First, intrinsic or pure semiconductor. Intrinsic or pure semiconductor is also called undoped semiconductor. In intrinsic semiconductor, there is no impurity, such as silicon, germanium, etc. Now, what is pure or intrinsic semiconductor? When there are 4 valence electrons in a semiconductor material, then the semiconductor is called intrinsic or pure semiconductor. Here, there are 4 valence electrons, 1, 2, 3 and 4. That's why this material is also called pure or intrinsic semiconductor, such as silicon, germanium, etc. In silicon, there are 4 valence electrons in the valence shell or the outermost shell, 1, 2, 3 and 4. That's why silicon is called pure or intrinsic semiconductor. Silicon is tetravalent element. Tetravalent elements are those elements having 4 valence electrons. In silicon, there are 4 valence electrons, 1, 2, 3 and 4. That's why silicon is called tetravalent element. This is covalent bonding in silicon. Silicon atom forms 4 covalent bonds, 1, 2, 3 and 4 with 4 neighboring atoms, 1, 2, 3 and 4. In covalent bonding, each electron is shared by 2 atoms, 1 and 2. Next, extrinsic semiconductor. When we add a small amount of impurity to an intrinsic semiconductor, then the semiconductor material is called extrinsic semiconductor. The impurity which is added to an intrinsic semiconductor is called dopant. The process of adding impurity is called doping. That's why extrinsic semiconductor is also called doped or impurity semiconductor. Next, types of impurity. There are 2 types of impurities, trivalent impurity and pentavalent impurity. In trivalent impurity, there are 3 valence electrons, 1, 2 and 3. But in case of pentavalent impurity, there are 5 valence electrons, 1, 2, 3, 4 and 5. Trivalent impurities are gallium, indium, boron, etc. And pentavalent impurities are phosphorus, etc. When we add trivalent impurity to an intrinsic semiconductor, here silicon is an intrinsic semiconductor and boron is a trivalent impurity. When we add trivalent impurity to an intrinsic semiconductor, it creates hole in the valence shell. So, it can accept 1 electron from neighboring atom. That's why trivalent impurity is called acceptor impurity. Here silicon is an intrinsic semiconductor and boron is a trivalent impurity. When we add pentavalent impurity to an intrinsic semiconductor, here silicon is an intrinsic semiconductor and phosphorus is a pentavalent impurity. When we add pentavalent impurity to an intrinsic semiconductor, it donates one free electron. That's why pentavalent impurity is called donor impurity. Here silicon is an intrinsic semiconductor and phosphorus is a pentavalent impurity. Next, what are p-type and n-type semiconductors? Next, what is p-type semiconductor? When an intrinsic semiconductor, that is silicon, is doped with trivalent impurity, that is boron, it becomes p-type semiconductor. P-type semiconductor has a large number of holes. So holes are the majority charge carriers in p-type. Holes are positive. That's why this material is called p-type semiconductor. Here P stands for positive, but the material as a whole is neutral. In this material, very small number of free electrons are present. That's why free electrons are the minority charge carriers. Next, n-type semiconductor. When an intrinsic semiconductor, that is silicon, is doped with pentavalent impurity, that is phosphorus, it becomes n-type semiconductor. N stands for negative, but the material as a whole is neutral. In n-type semiconductor has a large number of free electrons. So free electrons are the majority charge carriers in this material. Here N stands for negative, but the material as a whole is neutral. Electrons are negative charge carriers. That's why this material is called n-type semiconductor. In this material, very small number of holes are present. That's why holes are the minority charge carriers in this material. That's all. If you like my video, please like, comment and share. Thank you.